Sam's Club. Okay, all right, guys. Okay, all right. Let's breathe. Does anyone have any questions from the homework, page 169?
Did you say we have
Yeah.
How are we supposed to know about that?
I believe I announced it as you walked out. Yeah. You did. Don't worry about it. It's okay. It's all good. Don't worry about it. Number 17 says x minus the square root of 2x plus 5 equals 5. All right, so the first step when solving these is to isolate one of the radicals. Here it only happens to be one radical. So to get this guy isolated, it doesn't matter how you do it. You could add square root 2x plus 5 each side, then subtract 5, or you could subtract x from each side and then multiply those sides by -1, which you really don't have to do that either, but let's do it this way. Let's subtract x from each side. So by doing that, you have negative square root of 2x plus 5 is equal to 5 minus x. And from here, if you're comfortable going ahead and squaring right now, we can do that. So let's go ahead and square that. We square left-hand side, we get 2x plus 5, so a negative times a negative is positive 1. And then square root 2x plus 5 times square root 2x plus 5 is 2x plus 5. And then this guy here would become 25 minus 10x plus x squared. You need to definitely be careful and do it the long way. Actually, write out 5 minus x and 5 minus x. Go ahead and do that. Be careful. It's definitely not just 5 squared minus x squared plus x squared. There's definitely a little guy that needs to be accounted for. FOIL. And then now we have a quadratic, so let's get that equal to 0. Any questions thus far? Okay. So let's subtract 2x and subtract 5 from each side. So 0 is equal to 20 minus 12x plus x squared. Shrink the view a little bit here. Don't mind. So 0 is equal to, can we factor this? But first off, let me write it so it looks nicer. I like it in descending power. I think it looks a little bit easier to look at. All right, so for factoring, again, this would be, I guess, short AC method, where we just have to look at the C because the A is 1. What factors of 20 add negative 12? Yep, get a negative 10, negative 2. And you can even check it. I always have to check my work as it works. So x times x. You want to check your work. X times x is x squared. X times negative 2 is negative 2x. Negative 10 times x is negative 10x. Negative 2x and negative 10x would give you negative 12x. You add them together. And then negative 10 times negative 2 is positive 20. So you know you didn't make any mistakes in your factoring. All right. So
Wait, Mr. Rose?
Yes.
I'm sorry. Okay, so when I had this crane, I think it was for I don't know, or to, you know how it's like in the parentheses it says x plus negative 10. She usually either have us put the 10 in parentheses 10 or change the sum?
Okay, so we'll go the whole way through. Let's go the whole way through. So to be crystal clear, so let's continue here. So I could now say, because the multiplicative rule of 0, that this could be 0, or this could be 0. Right? Because they don't both have to be 0 at the same time. That's why we end up setting this whole thing equals 0 in the first place. So we continue here. We're going to add 10 to both sides. So you can clearly see that x could equal 10, or x could equal, if we added 2 to each side, 2. All right, so these are our proposed, right? These are our proposed solutions. Okay. We have to check to see if these are, check each one to see if they actually work. One of them may be extraneous, they both may be extraneous. So x equals 10. Are you guys fine if I just out loud check it?
Mm-hmm.
If I plug in 10, 20 plus 5, 25. So this is 5. 10 minus 5 is 5. 5 equals 5 is a true statement. So that checks off. If I plug in check in 2, 4 plus 5 is 9. This is 3. 2 minus 3 is -1. -1 equals 5 is a false statement. So the only one that works is this. So that would be your only solution. So you must check. Are you okay? You everything?
You recorded?
Is that the file?
You recorded?
Yes, being recorded. For your convenience. Anyone like to see any other problems before we move on?
Yeah.
Like to see one more? Okay, we'll look at one more.
Can we look at one of those ones that does all the long stuff?
A double radical?
Yeah.
So if we look back at, here, like number 27 on page 169. Here's another example of a double radical. I'm just going to go walk it through with you guys. So the blue is what's given. So if we look at here, next line down, I want to isolate this guy. It doesn't matter which one you isolate. If I decide I'm going to isolate this guy, so I'm going to subtract square root x minus 2 from each side, get to here. Now I'm here, and I decide that, okay, I'm now going to square both sides because I've isolated the variable, so I square both sides. This squared is this squared is this. Okay, again, you need to definitely do it FOIL the long way. You would get 4 minus 2 square root x minus 2 minus 2 square root x minus 2 plus x minus 2. Because the negative times the negative is a positive. And if you FOILed it, that's where you would arrive. And then the next line down we have here, I just went ahead and I combined like terms. So you notice this 4 here and this -2, they're both constants. 4 plus -2 is positive 2. I still have an x, and I still have this -4 square root x minus 2. And then, so now I want to isolate what I have circled here in purple. I want to isolate this guy. So I'm going to get rid of the stuff that's connected with it. I'm going to throw this away. So I get rid of this x, and I get rid of this 2 by subtracting x and subtract 2 from each side. So then you get x plus 1 equals -4 square root x minus 2. And now I say, okay, I could divide both sides by -4. At this line here, I could divide both sides by -4, but it's not necessary because if I square right now, I will get rid of the radical. Plus, I don't want to deal with fractions if I don't have to. So I decided, okay, I'm going to square both sides. So the square of x plus 1 is this. Again, if you do it the long way, you'll see that it's going to be x squared plus 2x plus 1. You FOIL. I think you guys have seen enough practice of foiling, but definitely do it the long way. And now this squared is 16x minus 2. Now you imagine you multiply negative 4 squared x minus 2 times negative 4 squared x minus 2, negative 4 makes 16, and then square root x minus 2 times square root x minus 2 is just x minus 2. I have a quadratic, expand, simplify, set it equal to 0. We've done a lot of these. I think you guys should feel pretty comfortable on these. You get to here. And now it's the, okay, is this factorable, right? Or do I have to use a quadratic formula? A lot of these problems are giving us, they're nice and factorable. And so I decide, okay, what factors of 33 add negative 14, negative 11, negative 3? I could write x plus negative 11 times x plus negative 3, or x minus 11 times x minus 3 means the same thing. So that means that this could be 0 or this could be 0. They don't have to both these at the same time, so then that means x could equal 11 or 3. You can already tell what's going to happen here, but x could equal 11 or 3. And then I get to this point, I say, okay, I need to test 11 and 3, so let's go ahead and test it. So if I plug in 11, into x, let's see what happens. 22 plus 3 is 25. So this square root of 25 is 5. Plus square root of 9 is 3. 5 plus 3 is 8. So the statement would say 8 equals 2, which is a false statement, a false equation. So 11 doesn't work. What's that?
Wait till you tap the board.
Sorry. You can write no solution. Good question. You can write no solution, or you can write this guy, this empty set symbol. It's like an O with a slash through it. But you can just write no solution.
Okay.
That's fine. And then testing 3. If we plug 3 back into the original, here and here, I would have square root of 9, which is 3, plus the square root of 1, which is 1. So 3 plus 1 is 4. 4 equals 2 is never true. It's a false statement, so that also is an extraneous solution.
So that's undefined.
It's not so much, I guess you could say that. We would just say there's no solution. I guess you could say there's no defined value for x. I guess you could say that. All right, so that's that. Any questions about this problem?
Hold on. So, oh, never mind.
Good?
Did you get negative 11 and negative 3 from from 33, right?
Yeah, so if you look here at this 33, short AC said, okay, this is 1. You can just look at the 33. You say, okay, what factors of 33 add to or sum to negative 14? And there's only going to be one pair that works every time you do this. All right. One thing too is don't just plug 11 and 3 into this line here, into your quadratic, which is the line just 2 lines above it. Don't do that. They definitely satisfy this line here, but that's not what we're interested in. We need to find solutions for x that satisfy the original equation, which was the double radical.
Mm-hmm.
Yes.
Are we going to go on the third?
I'm not going to focus on that right now. I want to go into the next chapter, the next part of that chapter.
Oh, what was the highest score?
In this period, off the top of my head, I'm not sure, but the highest score overall was a 100. someone did get 100%. Another person got a type 30, it was type 33, I believe. 31 out of 33. Those are the next files.
Yeah, everybody declined. The other classes fail too. A lot of them.
Yeah, overall it's not good. So that's why I'm just going to apply that across the board. All right, here is 17, and here's number 23, which you'll have also on the flip chart. All right, so going into this. All right, so this is now we're moving on to something that's actually not really too different than what you already know. We're looking at equations that are quadratic in form. Okay, quadratic in form. Okay. If you look at this, doesn't it seem like this looks like a quadratic in the sense that this degree of this term is exactly 1/2 the degree of this guy? Okay, so that's what it, in order for it to fit quadratic in form, that's what we're talking about. Okay, so anytime that scenario arises, we'd say it's quadratic in form. So here's what we do. We say we're going to let u substitution, we'll say let u be x squared. So we're talking about this guy right here, letting that be u. And then if u equals x squared, then what would x to the 4th be? Well, it would be u squared. Right, if I square both sides.
Where's you from?
U just came out of nowhere. That's just u substitution. It's like, okay, here's my placeholder. Then we'll do what we know, and then we'll substitute back in to get it back in terms of x. You'll see. Okay. So we take this guy, and so now we know that u squared is x to the 4th. So we have u squared minus 8u minus 9 equals 0. And now this probably feels even more familiar to you because this definitely is now a quadratic. Okay.
Why don't you do what you did?
All I did was I substituted for x to the 4th, I substituted u squared into here, and for x squared, I substituted u.
Just so it will look easy.
So it actually now is a quadratic.
She just changed the equation.
You change the way it looks, yeah, by letting u be x squared. You don't have to do this intermediary step if you can already see what's going on. Yes.
I was asking what happened.
No, you can use whatever you want. You want to use W, you want to use a smiley face. It's all.
So
It's okay. They just happen to use the letter
when you
U.
see an equation like that, whatever the number that like x equals, we make it whatever letter we want to do second.
Well, whatever this guy is, that's what you let U be.
Oh.
All right, so let's continue forward here. So now we have U. Okay, so now we're factoring, right? So we're at AC. So the question is, what factors of -9 sum to -8?
9 and 1.
-9 and +1. Almost right at, please. Next. And U plus 1. And you can check it too. I mean, I always check these as I'm working. I want to know right now if I made a mistake. I don't want to find out way down the road and have to waste a lot of work and a lot of time. So if I foil this, do I get back to here? Just a quick check. Yeah, U squared plus U minus 9U minus 9. Right? U times U times 1, -9 times U, -9 times 1. It checks off. So that's good. So now I can say that this equals 0 or this equals 0. So U minus 9 equals 0 or U plus 1 equals 0. So adding 9 to both sides, u could equal 9, or u could equal -1. In fact, let me just go ahead and plug in x right now. All right, so now this is where I'm going to plug in not x, but x squared, because u is x squared. So now I'm going to say that, let me shrink this down just a little bit. Now I'm going to say that x squared minus 9 equals 0, or x squared plus 1 equals 0. You see how that kind of that placeholder, that u substitution, how it works as a placeholder?
Oh, so you changed it back.
Yep, we went back, that's right.
Why wouldn't you just run the number that multiplies to 9 and 9 to, or negative 9 and 9 to negative 8, and then put x squared?
Yeah, exactly. So what Maya just said is completely true. There's no reason I can't just go from here to basically what we would say, what, x squared minus 9 times x squared plus 1. If you can do that, if you see it, just go ahead and do that. I'm showing it piece by piece using u substitution.
Does it matter that x squared is like x3?
We're gonna go into the next example of it that'll kind of answer what you're curious about. So now let's solve. Let's not forget, we're solving this. We're solving for x, so we're not done yet. I have x squared minus 9. What's that? I could do it that way. The only thing is that when you take the square root of each side, it's plus or minus, and some students could tend to forget that. So I'm just going to play it safe and know that this is a difference of squares. So it's technically x plus 3 times x minus 3 equals 0.
Wait a minute, where did it come from?
So this is a difference of squares. Difference of squares formula tells us that if I have like a squared minus b squared, that's equal to a plus b times a minus b.
Wait, so often.
You have to, difference of squares, you may have studied it, you should have studied it in the past, but if you haven't used it in a while, it may feel foreign. That difference of squares is just this guy here. We'll do a quick review. If I have a squared minus b squared,
Equals c squared.
that's, no.
I just put that in there.
Yeah, this is a squared minus b squared, which would be equal to a plus b times a minus b.
Okay.
Okay, do you remember difference of squares at all?
I don't think I've ever done that.
Okay, sorry.
Aren't you
So
just
what?
squaring the number and then giving the positive of it? Yeah.
What's that?
It's just squaring the number and then having a negative of it and then positive of it.
Like if I plug it back in?
Well, it was just the negative 9, you're just squaring it and then making one of them negative and one of them 1.
If I square negative 9, I would get 81. So let me show you another way, guys. Here's another way you can do it. It's fine to do it this way. If I have x squared minus 9 equals 0, I could add 9 to both sides. And so I'd have x squared is equal to 9. And then if I want to solve for x, I take the square root of both sides. I need to be careful and know that it's plus or minus the square root of 9 when I square root both sides. Yeah, it's not, it may be that, or it could be that you forget the plus or minus, and then you miss some of the solutions. So this could equal plus or minus, x would equal to plus or minus 3, which you can see here too. So there's two different ways to approach this. The only thing is, I don't want you guys to forget to do this. So I'm just going to play it safe and just go get different squares. I'm going to go ahead and erase this now. All right, so here I could say that this equals 0, this equals 0, so I could just say x could equal plus or minus 3. So that's some of my solutions. And now here, If you want to make it technically a difference of squares, I would do, okay, x squared minus -1 equals 0.
Or,
And so now, just like here, when I got x squared minus 9, the square root of, principal root of 9 was 3. What's the principal root of -1? What's the square root of -1?
0.
I. X plus I, x minus I.
I said square root.
Yeah, the square root of -1 is I.
I think it's square root.
And so x could equal plus or minus I. Alright,
why
so
can't it be plus or minus 1?
plus or minus 1, because that wouldn't satisfy us. Because, for example, let's go with plus 1. What's 1 squared? You asked why it can be plus or minus 1?
Yeah.
Okay, let's go ahead and try it. So what's 1 squared? 1 squared means 1 times 1,
1.
which is just 1. And 1 plus 1 is 1 plus 1 is
2. My bad.
is 2.
That
2
is
equals
one.
0 is not a true statement. And if you try -1, what's -1 squared? 1, and 1 plus 1 is 2. 2 equals 0, so it's definitely not 1 or -1. But if you try, let's say plus or minus I, just to test it right here, what's I squared? -1. Because I, let's not forget, I is the square root of -1. So I squared is -1. -1 plus 1 is 0. 0 equals 0, so it definitely satisfies it. And if you did -I squared, that negative I squared is just going to be I squared, which is -1. -1 plus 1 is 0, so it definitely are the solutions for that equation here. So the solutions to this equation that was given, the solution to this equation are plus or minus 3 and plus or minus I.
Well, all the equations.
Oh, what do you mean? Oh, what? Would they include, are you asking to include imaginary roots? They may. It's possible.
Mr. Gross.
Most likely, yes.
What's this x squared minus -1?
I just did that to show difference of squares. If you understand the difference of squares principle, that's why I did that. Just like here, x squared minus 9. Okay, x plus the square root of 9 is 3. X minus the square root of 9 is 3.
It's just weird that this is trapped in my
Again, if you're comfortable going from here and going, okay, then x squared equals -1, so x equals plus or minus I, that's fine too. Just be careful, it's plus or minus. Now, do you guys remember?
Oh, that makes sense.
Do you guys remember what I said about the degree of the polynomial equation? What that tells you?
How many solutions do you have?
How many total possible solutions you can have, including multiplicities. So, is it okay or does it make sense that we have 4? If this is a 4th degree polynomial.
Oh, yeah.
Yeah, it does. We can't have more than 4. Cannot have more than 4. And you can even test it. You can even test them and see that it absolutely is true. If I plugged in 3, it would make it true. If I plugged in -3, it would make it true. If I plugged in I, it would make it true. If I plugged in -I, it would make it true. The original equation. This is just difference. This is difference of squares. Difference of squares. I should have been taught this. I apologize if you were not.
Oh, my God.
Sorry about that. There's also difference of cubes and sum of 2 cubes. Should have also been part of your curriculum.
No, I don't know.
Example 7. We'll try to get this quickly, guys. Okay, don't let this scare you. I know it looks scary. I know it looks scary because the exponents are fractional. But I want you to notice something. This 2/3 is twice this, just like it was in the previous example. Yeah, what's 1/3 times 2?
Wait, is that a front?
1/3 times 2? 2/3. So just like before, I'll quickly go back. This degree was twice this one, so this is still quadratic form. This is twice this one. If it's not twice this one, you cannot apply this method that we're doing. Okay? Don't let it scare you, because watch, it gets real nice real quick. I'm going to let you, again, I'm going to let you be this guy right here. U is x to the 1/3, therefore u squared is x to the 2/3.
What about the other one?
Make sure you guys copy this down. Your homework is going to be to complete this problem. This is page 166, example 7. Try it on your own for homework. If you can't figure it out, the book does explain it out in detail. But if you try it on your own and you get it, you feel even better because, yes, I got it on my own.